Good morning, classics. Welcome back to your chemistry classroom once again. Today I am going to discuss different experiments about intermolecular space and expansion of matter. So let's start experiment 1. Basic mock experiment to show that intermolecular spaces are occupied. So what is the process? First experiment, add sugar to pebbles taken in a plastic beaker or sand to glass balls in a beaker. So in these two ways we can start our experiment. So first of all, we can take some sugar with pebbles in a plastic beaker or sand to glass balls in a glass beaker. Observation: the sugar or the sand goes into the space between the pebbles and the glass balls respectively. मतलब हम लोग क्या देखेंगे, बीकर के अंदर देखेंगे either sugar or sand goes into the space between the pebbles or the glass balls. Conclusion: an imaginative demonstration to show that intermolecular space between particles are occupied easily. So by this experiment we can easily demonstrate that intermolecular space between the particles are easily occupied. Next, experiment 2. Experiment to show that solids expand on heating. So on heating, solids expand. Experiment A. An iron bar is taken and its length measured accurately. So first of all, we can take an iron bar. After that, we will measure its length accurately. The iron bar is then slowly heated for a certain period of time. So after taking the length, we can heat the iron bar slowly for a certain time. And its length again measured accurately. उसके बाद हम लोग दोबारा उसका लेंथ मेजर करेंगे. Observation: it is observed that the iron bar has increased in length on heating. So after heating we can observe, हम लोग देखेंगे the iron bar has increased in length. iron bar का length increased हो गया on heating. So by this experiment we can demonstrate that solid expand on heating. Another experiment is here. A simple ball and ring apparatus is taken, like this process. Ring and ball experiment, which consists of a metal ball which can just pass through the circular metal ring. So in this way, if we want to pass through the ring, the metal ball just pass easily. The metal ball is then heated for a certain period of time. So after that, we will heat the metal ball for a certain of time. Observation: हम लोग क्या देखेंगे? After heating, the metal ball does not pass through the ring. So after heating, the metal ball does not pass through the ring. For what? Since on heating it has expanded in size. So after getting heat, the metal ball just increased in size. That's why it cannot pass through the ring easily. So conclusion में हम लोग क्या बोल सकते हैं? All solids expand on heating. So by this experiment we can easily prove that solids expand on heating. Next experiment. Same way, experiment 3, to show that liquids expand on heating. Same way, solid, liquid also expand on heating. Experiment: take water in a hard glass test tube and fill it up to its brim. Look at the picture at first. Take water in a hard glass tube and fill it up to its brim. First of all, हम लोग ऐसे टेस्ट ट्यूब में वाटर लिए up to brim, मतलब लास्ट एज तक हम लोग उसको फिल कर दिए. The mouth of the test tube is fitted with a cork with a capillary at the center of the cork. हम नॉर्मली टेस्ट ट्यूब का मुंह जो है ये कॉर्क से बंद कर दिए और उसका सेंटर में एक कैपिलरी घुसा दिए। कैपिलरी मतलब दैट इज अ ग्लास टेस्ट ट्यूब, थिन ग्लास टेस्ट ट्यूब। टेस्ट ट्यूब के अंदर एक ग्लास रॉड घुसा दिए, दैट इज कैपिलरी। ऑब्जर्वेशन ऑन हीटिंग, हीट देने के बाद द वाटर इन द हार्ड ग्लास टेस्ट ट्यूब राइजेस अप टू द कैपिलरी। क्या देखेंगे? आफ्टर गेटिंग हीट द वाटर लेवल जस्ट इंक्रीज अप टू द ग्लास कैपिलरी। Since water in the hard glass test tube has expanded on heating, यहाँ से क्या प्रूव होता है? So by the heating, just liquid expand and it goes up to the capillaries. So conclusion, all liquids expand on heating. Next, another experiment to show that gases expand on heating. Same way, solid as well as liquid, gases also expand on heating. Gases भी expand होता है after getting heat. कैसे प्रूफ करेंगे? Take an empty hard glass test tube fitted with a cork having a capillary and its center. Colored water is carefully poured into the capillary. So क्या किए? पहले एक empty test tube ऐसे ऐड कर दिए और उसका मुंह कॉर्क से बंद करने के बीचों बीच एक कैपिलरी घुसा दिए, जिसके अंदर हम कलर्ड वाटर पोर कर रहे हैं, मतलब कलर ऊपर से बाहर से कलर वाटर पोर कर रहे हैं। सो आफ्टर गेटिंग हीट हम क्या देखेंगे? कैपिलरी के अंदर नॉर्मली जो कलर वाटर है, सो द लेंथ ऑफ ये कलर्ड वाटर जस्ट इंक्रीजेस बाय द गेटिंग हीट। सो आफ्टर गेटिंग हीट, ये हीट पाने के बाद कलर्ड वाटर का जो लेवल है ये ऊपर की तरफ इंक्रीज हो गया। So on heating the test tube, the colored water is seen to rises up inside the capillary. Since the air inside the empty test tube has expanded on heating, so यहाँ से क्या प्रूव होता है? नॉर्मली ये टेस्ट ट्यूब के अंदर जो एयर ऑलरेडी प्रेजेंस है, the gas has expand on heating. Conclusion, all gases expand on heating. So the last portion of this chapter, intermolecular forces. These are Brownian movement, diffusion and cohesive force. These three definitions are very important and you will try to understand. First, Brownian movement. The random zigzag movement of particles suspended in air or water is called Brownian movement. मतलब the particles actually always float either air or liquid in a zigzag movement. मतलब ये सिस्टमेटिकली अरेंज नहीं होता है। मूवमेंट्स जो है ये नॉर्मली जिगजैग होता है, इधर से उधर, उधर से इधर, ऐसे सिस्टमेटिकली अरेंज नहीं है पार्टिकल्स। ये नॉर्मली ब्राउनियन मूवमेंट जो है कहाँ पे हम फॉलो कर सकते हैं? आइदर गैस और लिक्विड। सो द zigzag movement of particles, random zigzag movement of particles suspended in air or water is called Brownian movement. बहुत अच्छे से definition याद करना। Among the three states of matter, Brownian movement is maximum in gases. So among the three states of matter, we can see Brownian movement is maximum in the gaseous state. There is very large intermolecular spaces in them. For what? Because the particles are very loosely packed. That's why the intermolecular space between them is largest among the three states. That's why it can easily follow the Brownian movement is possible. Either three states, मतलब तीनों states के अंदर gaseous state में सबसे ज़्यादा होता है. In solids, the intermolecular space is minimum. Hence, the Brownian movement is negligible in solid. मतलब इन केस ऑफ सॉलिड द इंटर पार्टिकल्स, मतलब जो गैप है ये गैप बहुत कम होता है। इंटर पार्टिकुलर जो स्पेस है ये बहुत कम होने के कारण ब्राउनियन मूवमेंट भी बहुत कम दिखाई देता है। दैट्स वाई ब्राउनियन मूवमेंट इज नेग्लिजिबल इन केस ऑफ सॉलिड। नेक्स्ट, डिफ्यूजन। Intermingling of particles of two different substances on their own is called diffusion. मतलब दो टाइप का डिफरेंट सब्सटेंस के अंदर पार्टिकल्स का जो नॉर्मली एक्सचेंज होता है ये एक्सचेंज को हम लोग क्या बोलेंगे, डिफ्यूशन. सो डिफ्यूशन इट इज द इंटरमाइनिंग ऑफ पार्टिकल्स, मतलब एक्सचेंज ऑफ पार्टिकल्स फ्रॉम टू डिफरेंट सब्सटेंसेस. दो डिफरेंट सब्सटेंस के अंदर पार्टिकल्स का जो एक्सचेंज हो रहा है, दैट इज ऑल्सो नोन एज डिफ्यूशन. In solids, particles do not diffuse, while in gases they diffuse rapidly. ये लाइन बहुत अच्छे से पढ़ना. Particles do not diffuse, while in gas they diffuse rapidly. So in case of solids, diffusion it, मतलब diffusion is not possible, but in case of gas they diffuse rapidly. The last one is cohesive forces. The interparticle forces of attraction between atoms or molecules of the same substance are called cohesive force. मतलब एक सब्सटेंस के अंदर एटम्स और मॉलिक्यूल जिस अट्रैक्शन के द्वारा एक दूसरे के साथ जुड़ा रहता है, उस फोर्स को हम लोग क्या बोलेंगे, कोहेसिव फोर्स. सो कोहेसिव फोर्स इज अ फोर्स ऑफ अट्रैक्शन by which atoms or molecules of same substance combine with each other. That is cohesive forces. The cohesive force is maximum in solids and negligible in gas because it is totally different incident from diffusion. जहाँ पे ये normally solid के अंदर diffusion हम लोग नहीं कर सकते, वैसे cohesive force is maximum in solid where it's negligible in gases. So student, hope all of you understood what I've discussed in this long video. So for today, up to this portion.